A boiler has 5 identical relief valves. The probability that any particular valve will open on demand is 95%. Assume independent operation of the valves. Calculate the probability that at least one valve opens. Round your answer to 8 decimal places. Calculate the probability that at least one valve fails to open. Round your answer to 4 decimal places. We are performing the experiment of turning on 5 valves. Each valve can either open on demand or not, with a 95% chance of it functioning properly and a 5% chance that it will fail to open. We are told to assume independent operation, so the likelihood of a valve opening on demand is not dependent on how another valve in the group functions. The likelihood of a valve opening will stay consistent throughout the experiment. For each of the 5 valves, there are 2 different outcomes. It will either open or fail to open. This gives us a total of 32 possible outcomes. We can visualize these outcomes through a tree diagram, which gives us our sample space, the set containing all possible outcomes for the experiment. The probability of an event occurring that is within our sample space is certain or equal to 1. For this problem, we will use the complement rule, which states that the probability of an event plus its complement is equal to our sample space, which is 1. Where the complement is made up of the set of elements that are not in our event A, but are in our sample space. We are asked to find the probability that at least one valve opens. This event contains the set of outcomes that has one or more valves opening on demand, which is 31 of our 32 possible outcomes. When working with independent events, we find the probability of an outcome by multiplying the probabilities of the individual events. Once we find the likelihood for each of these outcomes occurring, we would then take the sum of these 31 probabilities. But we can easily avoid these computations by working with the complement of this event, the outcome where none of the valves function on demand. Multiplying the individual probabilities that none of the valves open, we have 0.055 times. And subtracting this value from 1, we get 0.9999969 probability that at least one valve will open. For the event where at least one valve fails to open, the approach is similar. Again, we will have 31 of our 32 outcomes that belong to this event. But this time, since the event is asking for the set of outcomes where one or more valve does not release on demand, the complement of our event would be the set of outcomes where all 5 valves function properly. Multiplying the individual probabilities of all the valves opening is 0.955 times, and subtracting this from 1, we get 0.2262 probability that at least one valve will fail to open.